Yeah, I'm going to talk about some of my adventures in writing bindings that I've had over the last year or so. My name is Graham Ollis. I'm known as Platypus on the internet in most places that I frequent. And oh, by the way, I work at Fastly and we're hiring. We're always hiring, but specifically we're hiring for a slot on my elite team of Perl and Go developers. We are control systems and we collaborate with multiple internal Fastly teams, support critical initiatives. We focus on the management, compilation, and validation of customer configuration, including propagation of those configurations to the edge. Fastly helps people stay better connected with the things they love. Fastly Edge Cloud Platform enables customers to create digital experiences quickly, securely, and reliably by processing, serving, and securing our customers' applications close to their end users as possible at the edge of the internet. The platform is designed to take advantage of modern internet to be programmable and support agile software development. Fastly's customers include many of the world's most prominent companies, including Venmo, Pinterest, and the New York Times, and this a little website you may have used before, GitHub. So if you're interested, flag me down, ask me questions while I'm here. Okay, so what are bindings anyway? They're kind of like wrappers that let you call a library in another language. What is FFI? If you've ever seen me give a talk, you've probably already heard me ask and answer this question, but basically it's better bindings for Perl than XS. I once heard someone complain that the only thing about FFI that was easier than XS was its documentation. And I'm not a professional technical writer, so I think it's a pretty damning indictment of the state of XS documentation, if that's the case. What's Platypus? So it's a framework for using FFI in Perl. The killer feature, I think, because before Platypus, there had been a few of these. The killer feature is that you can attach a foreign function like a real Perl subroutine. And there are technical reasons, but it's much faster than if it's an object that you have to call a method on to call the thing. So a couple years ago, I gave a talk about some new relic bindings that, for reasons, are called newfangled. Beyond this specific application that I was talking about, it was just really an example. It was really a talk about how to use Alien and Platypus together to write simple bindings for Perl. So I kind of like to think of what I was covering in that talk as Bindings 101. And there's a video on YouTube. And I also, at the same conference, I gave a sort of a lightning talk on, it's kind of a companion piece on how to bundle your foreign code with Platypus. Today, though, I like to think of what we're going to talk about today as Bindings 201, or technical techniques for more challenging bindings. But if you weren't here for the first talk, don't worry about it. This stuff is still interesting and relevant if you're interested in doing this kind of thing. And you can go check out the YouTube for the older material. Someday, though, maybe, I will give a talk about Bindings 301. Or maybe somebody else, actually. I'd be happy. I like to think this will be about what the next steps are going to be to make bindings even easier. And I'm not exactly sure what that's going to look like, but I'm going to make some guesses at the end of this talk. So let's start with libarchive. This is sort of my de facto example. This was like the first, these are the first bindings that I ever wrote using FFI. Libarchive is a multi-format archive and compression library. It lets you read and write any sort of archive you can think of and compressed in any sort of format you can imagine. One of the neat features is that archives can be processed without a lot of copies, so it's very efficient. And it's basically the tar implementation on FreeBSD as a library. Although I think other BSDs are using it now as well, because it's actually really good. Better than GNU tar, in my opinion. And you can also use it on Linux as well. The big challenge for writing library bindings for libarchive on Perl is that there are literally hundreds of functions that you have to write binding for. And you don't want to do all of those by hand. My first attempt at writing these bindings for this library was archive libarchive FFI, and that was the basis of my very first YAPC talk, in which I used FFI raw to implement these things. It gets the job done, but it was really difficult to maintain because I made all sorts of interesting design decisions, and I don't mean interesting in a good way, but it was helpful in that the challenges that I had there informed the development of Platypus. So more recently, I've written new bindings. I called it archive libarchive. I dropped the FFI suffix because it's unnecessary. And this is a truly comprehensive set of bindings for libarchive using Platypus. I did this because, so the bindings are mostly generated from C header files that come with the libarchive. And I did this because, like I say, there's hundreds of functions and we don't want to do them manually. And more importantly, actually, doing it manually would be very error prone. So in order to do it automatically, I had to programmatically sort of understand the C code, which is not an easy task. There's this thing called cast XML. I feel kind of dumb, actually. I just realized this morning that cast XML is probably short for CAST XML. Anyway, this is a utility that takes a header file and it spits out the abstract syntax tree of all the interfaces in the header file in XML format. I also use the C preprocessor to compute the values of various macros because in some, like, C is like, there's more than one way to do it and you can do constants in lots of different ways. And if you have, well, we'll talk about that in a minute. Anyway, I wrote a module to do that because like computing those constants is sometimes not trivial. And then I generate, the Perl bindings using a template. I'm not going to show you this code because it is not pretty. But we'll talk a little bit later about how maybe we can improve that situation. A lot of the functions can't be generated automatically because the C ABI is a little ambiguous. So like this function, this is just an example. This returns, okay. So this function returns a region of memory or a buffer, which is basically beginning and an end of memory, in the form of a pointer, a size, and an offset. But you kind of need to be a human being to understand that. Yeah, the libarchive went to a lot of effort to not do a bunch of copies. I don't want to do a bunch of copies either. So it'd be nice to not to have to copy that data from C space into Perl space in order to get the results. Thankfully, Platypus has this buffer module with a window function that gives you sort of a read-only window into a region of memory in the form of a scalar. So it looks like a scalar, but it really just maps to this chunk of memory that libarchive is returning to us. And now we can use it really easily. We don't have to understand how that works under the hood. Libarchive does the same thing with writes. And now we can, let me see. Okay. This goes the other way. There's also a scalar to buffer method, which takes basically a scalar and it returns the actual memory location of the data stored in there. And you can pass that into C. So now I'm going to talk about libcurl. this is going to be the second of our two big bindings. And probably curl doesn't need an introduction, but I'll say curl is a command line and C user agent, C library user agent. It doesn't have as many functions as libarchive, but it does have like hundreds of constants. So again, there's a lot of stuff that we want to include in these bindings that we don't want to do by hand. It uses some of these constants with veridic functions to implement a lot of different functionality. So when I was writing the curl bindings, I used the same technique broadly as with libarchive. That is, I used cast XML and the C preprocessor using my module, but I couldn't really use the same tool. I couldn't use the same code to actually generate those bindings because like the interface is just radically different. So back to veridic functions. It's like this funny C thing where you can pass in a variable number of arguments using this ... notation. And Platypus, since about version 1, which is actually the second version, I started out with 0, has supported veridic functions using this like 2 array notation. And that is the first array references like the fixed arguments. And I don't know, for reasons, veridic functions require at least 1 argument. I'm not sure why. 1 fixed argument. The second array is your variable arguments. And unfortunately, because of the way attach works and stuff like that, if you have different signatures with different variable sets of arguments, you need to attach each one if you're using that approach. Which is why sometimes you don't want to attach these functions, and instead you can create them dynamically and call, and that saves like some memory, but it's also at the cost of some performance. For some things, it doesn't matter. For curl, though, there are actually really just a few small subset of veridic signatures that we have to worry about. So I attached just type-specific variants of the veridic function set opt functions here, and I wrote a Perl sub to wrap around them. And that maps given the particular constant you're interested in, it maps to the correct X sub based on the enum option, so the constant that got passed in. The opt hash here, this is actually spread over multiple files in the actual implementation, but the opt hash is generated from these tools that I wrote. The keys are basically the name of the constant, and the values are the value of the constant and the function that should be called for that particular option. So one nice thing about this approach is that the key is a string. So you pass in a string, and you don't have to like import a million constants from my bindings. So let's talk a little bit more about code generation. I've been thinking about like a companion tool for Platypus for a long time. Something that could generate Perl bindings from a C header file in sort of a more automated kind of way. Privately, I've been calling this echidna, as that is the platypus's closest living relative, and they're cute like platypuses, so that's good. My idea here is to have input libraries that can introspect things about the foreign language, then feed it into an intermediate model. And here's where you might be able to deal with some of the ambiguities in a language like C. By providing an API to the intermediate model, you can adjust the guesses that these tools make in determining what the functions mean. Then once you have this intermediate model, you can generate the code. And if you do it like this in the right way, it doesn't have to be necessarily Platypus bindings. It could be XS or Raku, or even a totally unrelated language like Ruby or something like that. And I've tried to do this a couple times. I've had a few false starts, and usually I kind of break down when I'm kind of trying to think about like what the model should look like. And I'm starting to realize that I'm probably never going to get this done. I don't really have the bandwidth for it at the moment, but maybe somebody else can pick up this idea and run with it. That'd be awesome. Or maybe you have a better idea how to handle this. Let's talk a little bit more about the C code introspection for a minute, though. So libclang is this library that you can feed it some C code, and it will give you the abstract syntax tree. Unfortunately, whomever wrote this libclang, they didn't consider that somebody might want to use it for something other than C++, basically, because it's all very sort of C++ specific. I try not to be judgy, but it's as an interface, it's kind of ugly, I think. Fortunately, like I say, somebody wrote this cast XML, which uses the libclang to generate the AST of just the interface stuff. So exactly what I'm interested in. I don't care about the actual guts of each of these functions. I just want to know what the signatures are, and maybe the constants and enums and types and things like that. And it outputs XML. Unfortunately, the C preprocessor is a thing. libclang and castmxl know nothing about this because the C preprocessor runs before the C code is even compiled or parsed, rather. So I wrote this, like I say, const introspect C, which does some of the magic to extract the values and constants from headers. And so in the example I have here, like an enum, libclang will know about because that is part of the C language. But this pound defined foo constant it just disappears after the C preprocessor runs. So that's kind of why we need like two tools to get everything. It's also unfortunate that the C ABI is pretty ambiguous. Here we have an example of a C function that takes a pointer to an 8-bit byte, but we don't really know what this means. Is this like, usually this is like a string, but it could also be, it could be like writing an integer into this memory location. It could be like an array of bytes, not intended to be a string. It could be lots of things. And without looking at the documentation or reading the source code, it's really impossible to know for sure. And most likely you're going to need like a human being to actually look at this and understand like for sure what it means. All of these things make generic binding generator for C really difficult. Okay, so lighter subject, let's talk about our little binding. For work, I needed to implement a rate limiter that used memcached to track client usage. Basically, we get lots of requests and we got to make sure that no customer is like abusing our API and causing failures and stuff like that. So I wrote this thing using Platypus and Rust. And why write a new module though? There are like a ton of memcache clients for Perl already. Unfortunately, at least when I was working on this, none of them supported TLS connections. And for security reasons, encrypted connections were a hard requirement. Crates.io, which is sort of Rust's CPAN, has a memcache client that supports TLS. And by the way, actually, like memcache, it's like even having TLS in memcache is like a new thing, because it's been around for a long time. And when it was implemented first, like people didn't really, you were on a closed network and you didn't really think to worry about it. And maybe we don't even need to either, but except for we have, security people have rules. It's also important that Rust has better memory safety than C, making it easier to review this code. So I could show it to people and say, they could say, yeah, I think that's safe, more easily. And so I was able to get this thing out to production relatively quickly. Platypus has a Rust plugin, which lets you use native Rust types. This is a very simple example of a Rust function that adds two numbers and how you call it from Perl using Platypus. Honestly, I really get tired of this type of example. I see it all the time for other languages in FFI stuff because, like, who cares? Like, you never need to do this. This is not like the interesting problem. More likely, you're going to need to interact with some sort of object in another language, and this is an example that I pulled from the Rust plugin documentation. Here we have a person struct with some methods that you can call on it. If you don't know Rust, just take my word for it, I guess. Rust doesn't have a stable ABI, though, so you can't directly call Rust functions from Perl using FFI, but you can tell Rust to use the C ABI, which is sort of the lingua franca of ABIs. Yeah. And that fewer new projects are like using C nowadays. Like a lot of projects are using different languages like Go or whatever. But C has been around forever, and it's a common ABI. And so two different languages, if they're talking to each other, are probably using the C ABI, even if neither one of them are C. Anyway, here we take the person's name as a string and create one of these person objects, which we convert into a raw pointer. Rust code no longer owns this pointer, so it won't drop or free it, as it normally would when it falls out of scope. But don't worry, we'll free it later. We won't lose the memory. Unfortunately, every time we pass the pointer back into Rust from Perl, we have to cast it back from a raw pointer into this person object. In Rust, this operation is considered unsafe, so you have to specify. You have to tell the compiler that you're going to do something that is unsafe. This is most helpful because, thank you. When you're reviewing this code, you can say, this is something that I need to pay attention to. So anyway, C would be like, whatever, I don't care. I'll do anything with that pointer you gave me. But Rust cares. This is a wrapper around one of the accessor methods that I wrote for the struct. And now that we're done with the object, we want to pass it back into Rust to actually deallocate the memory. So where's the free or the drop? Well, you can explicitly drop an object in Rust and it will do the thing that you want it to do, but you don't need to. As soon as this drops out of scope, it'll be freed. Interestingly, actually, if you go into the Rust standard library and find the implementation for drop, it's just basically an empty function like this. It just takes ownership of that thing, and now that it no longer needs it, it frees it. So I think that's kind of interesting. Writing bindings for the person, this person object is trivial now because we chose sensible names for our wrapper functions. And I always like to I usually like to prefix my foreign functions with something to do with the module, and then tell Platypus to mangle the name by just using that prefix for all of the lookups. And Platypus allows you to create a type alias, which is just a blessed reference to that opaque pointer. And I think like a diagram is kind of helpful in this case to understand how this works. What we call an opaque type in Perl, or in Platypus rather, is just an integer value, which is actually the pointer that we pass back and forth. And when you bless a reference to that opaque scalar like this, you get this platypus object type, and the platypus system just it makes sure that the class is appropriately blessed, and so you don't end up passing in like a dog class into a function that's expecting a person. We can make this safer though, and this is what I did for my rate limiter module. I have this object. This is sort of a Rust thing that I wrote, and forgive me for omitting the details. This is just about the interface stuff. But we can treat this thing as an opaque type and not worry about like the internal representation from Perl. In fact, we can even avoid passing a pointer into Perl space. Here is the wrapper, which will eventually become the constructor for our Perl class. And instead of returning a pointer, we stuff one of these rate limiter objects into a hash map. That's basically a hash reference in Perl terms. So, and the key for this hash map is an integer index, and we just increment it for each new one that we need. And if you're familiar with like the way file handles work in, is it C or Unix? In Unix, I guess, this is kind of the same idea. Now, the only thing that is unsafe in this constructor is when we pass in the string. And for now, at least, I think that's kind of unavoidable. I'm not sure if there's a good way to handle that at the moment, but maybe we'll think of something. Now, when we need to call the rate limiter method that actually does the actual work, we take that same integer handle in and fetch the rate limiter struct from the hash map. This function is a little messy but not really so much because of the hash map stuff, because it has to deal with errors, and there's not really like a Rust native way to just return an enum from to Perl, at least not yet. For the destructor, we are explicitly removing the index handle from the hash map, and this will have the effect of freeing the memory for that index. And again, the Perl code is pretty brief. When we create a type alias for memcache rate limit, we specify the underlying implementation type as U64 instead of opaque. Actually, opaque is the default. So you probably don't remember, but in the previous example, it just specified the package name. And there's some monkey business getting the index from the constructor wrapper, but this is not too bad. And finally, we create a limit object, rate limit object, and we can rate limit requests as though it's just a regular Perl object, because it is just a regular Perl object. We just don't have to worry about the implementation. So again, let's do a diagram. I think it's helpful. The class is still represented in Perl as a reference to an integer value, but instead of being a pointer, it's an index into this hash map. And Rust knows about where that is actually stored. Rust is happier because there's less unsafe code, at least from its perspective, and I'm happy because I can show this to somebody, they can review it, and they can see that it's safe. The cool thing about writing Perl bindings using Rust, using this Rust plugin, is the cargo ecosystem, which lets you define dependencies on other Rust crates. And it all just sort of works. A crate is in Rust what we would call a distribution in Perl. And this is my crates.toml file for the rate limiter, and this is what specifies, among other things, the Rust dependencies that I have. And kind of a cool thing that I sort of ran into when I was working on this was that for my bindings, I realized that there was sort of a problem with the upstream library that I was using, which was that it would on a bad connection, it would take 5 minutes to time out, which would have been pretty disastrous if the memcached server just like disappeared for any length of time. So, but using the cargo.toml file, I was able to specify an alternate branch basically to use for that dependency. While I was waiting for the upstream project to merge my PR, which they actually did really quickly, but I was very excited about this because this is a lot harder to do in Perl. I think you can do it with CPAN Plus and some distro prefs, but of course we don't use any of that in our build infrastructure. So anyway, that was exciting. So I didn't use any code generation for this project because the number of bindings that I was writing was like a small number. But in our theoretical project Echidna, we could use the Rust syn crate to do everything that const introspect C and cast XML does. Only it would be a lot better, I think, because you don't have the ambiguities the way C does. Like the syn crate, when it creates its abstract, its AST or whatever the equivalent is, knows a lot more about what these different functions and methods and stuff are, or what the types and things like that. So let's talk about the future. What would that hypothetical bindings 301 look like that I talked about before? Well, I do have some thoughts, but I'm also interested in anything you can think of. So, like I say, track me down, or we'll have some time for some questions as well. But let me talk about some of my ideas. Entirely by coincidence, a friend and coworker of mine, Dylan Hardison, the other day started working on MySQL database driver for DBI using Platypus and the Rust language plugin, because he was fed up with the state of transactions in the existing MySQL database drivers. Dylan once confided to me, actually, that he didn't want to become the database guy at work, but this is a thing that he chose to do. Anyway, he rightly didn't want to write Platypus bindings by hand, so he started working on this new project that he called PL-bind-gen to automatically generate Platypus bindings. And the name is sort of a play on cbind-gen, which is a Rust tool that generates C header files that can help call Rust from C or C++. And he told me that the P and the L stand for both Perl and Platypus. So I like that. This is still really early days, but it already does some really cool stuff. And it's, yeah. Dylan described it in his README as an H2XS for Rust that you'll probably enjoy more than using H2XS. And that quote made me laugh, which is why I put it in the slide. And Dylan specifically asked me to credit him when he was reviewing my slides. So, yeah. So let's do a really simple example on how this works. And here's this example that I just told you that I am tired of seeing because nobody ever needs to do it for real. But I promise PL-bind-gen supports more useful types like records and opaque types. So PL-bind-gen has this companion crate called PL-bind-gen macros that lets you annotate your Rust code so that PL-bind-gen can generate appropriate bindings. So in this case, we're using the export macro that makes sure, number one, the function is public, so it's callable, turns off name mangling, which is, I thought was necessary. He told me that he got some mixed results when he was trying to figure out if it was necessary or not. And that it uses the C ABI, which is like, again, that lingua franca that we need. There are, as I mentioned, macros also for opaque and record types. So you can just tell, so PL-bind-gen can know the right thing to do for a particular type. And actually, like these Annotations, this is a normal thing to do in Rust, and they're really, I find, not intrusive at all. In fact, it's much simpler and easier to read than like when you're setting all these things manually. Now, anyway, now that we have our annotations in place, we can run PL bindgen. And this is the platypus bindings that it generates. So I'm actually really excited about this project. I think I would probably have used this for my little Rust module had it been available at the time. Okay, new subject. One place where FFI can be quite slow compared to XS is that if you have nested data structures. For example, if you're writing a JSON deserializer, there are a lot of objects that have to be created in C space because you don't have access to that Perl API we call XS. One thing that might make even the odds on that sort of transaction is Rust has this library called SWIG, or I think calling it a library is probably not quite right. It's more of like a convention for how to serialize and deserialize things. Anyway, it's very flexible, and you can plug in like different formats on either side. Anyway, Perl could be one of those formats. So you could, in theory, directly convert a nested Rust structure or something like that into a Perl data structure and go like both ways relatively fast, I would think. And with the right macros and tools built into into Rust rather, potentially, it could be pretty easy to do, possibly. Mm-hmm. Yeah. So, and you could also, like, for free, I think if you did this, you could pretty easily just plug in anything that SWIG supports into Perl using this as well, which would be awesome. Well, we haven't actually, this is theoretical. Yeah. I don't know. There's some, I think, kind of big challenges in this. Like Dylan has started playing around with this because Dylan's obsessed with Rust. One thing would be like actually linking the Rust code back to the correct Perl runtime, like getting that right is just going to be, I'm used to doing that stuff with Alien though. It's a thing that's complicated. But this is the dream. And I think it would be pretty fast and pretty cool if we could do it. Okay, the other thing is, for better and mostly worse, the C ABI is, as I said, sort of the lingua franca of computer languages. It's been around since the 60s or 70s. And honestly, it served us pretty well, given its age. I don't want to complain too much. But there are some serious challenges, like it's not inherently memory safe. As I mentioned a couple times, it's very ambiguous, which in particular for writing bindings and especially automatic generating of bindings means you have a lot of guesswork and probably a fair amount of human intervention, even if you're automating a lot of this. Which any sort of manual work we should kind of like especially for bindings that have lots of functions or lots of constants we want to avoid. Rust, unfortunately, doesn't have a stable ABI by default, meaning from version to version, you can't count on a particular calling convention. This is a strategy that like most modern languages use, it seems like. It gives them the flexibility to optimize function calls without breaking existing code. Yeah, without having to commit to a particular calling convention. So Rust can, as I mentioned, use the C ABI, which is what it ends up doing when it needs to talk to another language. There is talk in the Rust community about implementing an optional stable ABI, which could be used by other languages or binaries compiled by different versions of Rust to talk to each other. And in theory, like any sort of like memory safe language that is sort of on par with the way Rust thinks about how to structure things could use this ABI. And it would be memory safe, and it wouldn't be ambiguous, and it might even allow us to use Rust native types like enumerations across the FFI boundary. I also just want to briefly mention WebAssembly as a safe way to write bindings for Perl. WebAssembly is really cool. I don't directly work on any of that stuff, but we use it at Fastly, and I've even dabbled with using it from Perl, using, of course, FFI, or Platypus, rather. Gavin Hayes is giving a talk on Thursday. Yeah, definitely go check it out. I'm really excited about that subject. If you're interested, that's a thing that you should do. Anyway, thank you very much for coming to my talk. I'm, as I keep saying, Pisces on the internet. Why is it spelled that way? I'm not sure. It's a totally made up word. So I've got nobody but myself to blame. There you go. There's also like a Perl FFI Mastodon account and GitHub org. Dylan's new PL BindGen project is hosted there. Oh yeah, and I'm also on, there's a native channel on Perl's IRC server that we sort of hang out on to talk about both Platypus stuff and Alien, which is another open source Perl project that I work on. Yeah, so anyway, does anybody have any questions right now? Yes. So there's I think a project called GP Trixie. Yeah, there might be some overlap. That might be really useful. Thank you. Anybody else? Okay, well, I'll be around. Oh, yep, go ahead. Yeah, it's a good question. I do try I actually do try to be there once a day or so, except for like I'm on vacation or something like that. IRCs or even actually Mastodon, just like pinging me on at Mastodon is sometimes a good place to do, because I do check that once every couple days. Sorry? Yeah. All right. Well, thank you very much. And yeah, and if you're interested in knowing more about Fastly or anything like that, please let me know. I'm happy to. I will give you the inside scoop. I want good people to be on our team. So yeah. Anyway, thank you very much.